5a, the question asks, write down a reason why the company should not justify their claim by testing all of the PCs they produce. Well, if they tested everything, then they'd have nothing to sell. So we'd write an answer something like this. So if you write something like, the seeds would all be destroyed in the testing, so they would have nothing to sell. So for part B, it says a random selection of the pea seeds is planted in 10 trays with 24 seeds in each tray. Assuming that the company's claim is correct, calculate the probability that in at least half of the trays, 15 or more of the seeds germinate. So what I've done is I've summarised some of the key information here. We've got 10 trays, there's 24 seeds in each tray, and in each, overall, there's 55% of the seeds germinate. So what we're going to look at in step 1 is if 15 or more germinate in one box. So this is going to be, X is going to belong to the binomial distribution. And remember, we've got an N and we've got a P. Now, our N for this is, there are 24 seeds per tray. So I'm going to put 24 in here for my binomial. And the probability that they germinate is 55%. So our P is going to be 0.55. Now we want to find the probability that X is greater than or equal to 15 of those seeds germinate in that box using the binomial. Now what I've drawn down is a helpful guide to try and work out the probability that X is greater than or equal to 15. So think of the values that we want. We want greater than or equal to 15, so it's 15 all the way up to 24. So remember, when we're going to write our probabilities, you've got to write these as a less than or equal to. So the probability of greater than or equal to 15 is going to be 1 minus the probability that X is less than or equal to 14. So it's all these probabilities down here below the 15. And that's what we're going to key in on our ClassWiz calculator now. So on the calculator we want menu 7, and then we want binomial CD. So we have to arrow down, 1 for binomial CD, 2 for variable. Now let's put our variables in. Our X, we wanted X to be less than or equal to 14. So we want 14 in there. Our N, the number of seeds in a box, was 24. And our probability was 0.55. Press equals, and we get 0.70087. So we want equals 1 minus 0.70087, and that comes to 0.299126. Now for the next step, out of 10 trays, half or more have to germinate. So if we think half or more, it's going to be 5 or more. So if I highlight this here, I've got 5, 6, 7, 8, 9 or 10. So it's going to be a binomial again. So we want to get, it's going to be greater than or equal to 5. So that's going to be 1 minus the probability that X is less than or equal to 4. Now what's our binomial distribution this time? We've got X belongs to binomial, 10 is our number, and our probability we got up here just a few seconds ago was the 0.299126. And then we're going to go and use our ClassWiz calculator with the binomial and find the probability of X is less than or equal to 4. So on the calculator again it's menu 7, and we want binomial CD, so arrow down, number 1, 2 for variable. Now this time X is going to be less than or equal to 4, press equals, our n value is going to be 10, and our probability is going to be 0.299126 equals, press equals again. So we get 0.8512. So working that out then, we want one takeaway. Our value we worked out there was our 0.851226, and that comes to a final answer of 0.14877. Part C asks us, write down two conditions under which the normal distribution may be used as an approximation to the binomial distribution. Well, this is a standard answer to learn, that the normal can approximate the binomial when n is large, that's the first condition, and also p has got to be close to 0.5. Now I've summarised the key part to start 5D. We've got 240 planted and 150 germinated. So our n is going to be 240, and our p from the first part of the question is 0.55. So these are both conditions where we can use the binomial. So what we're going to do is we're going to use the binomial approximated by the normal distribution. So we've got some transformations to do, because we've got binomial NP and we need to transform that into normal with a mu and a sigma squared. So for this transformation, we make mu equal NP. So in our case here, we've got our n is 240 times 0.55, and when we do that on the calculator, that gives us a mu of 132. And then we need to get our sigma, our standard deviation, and our sigma is square root of NP brackets 1 minus P equals. So if I put that into the calculator, we're going to have square root of, now our NP we just worked out there was 132 brackets 1 minus P, our P was 0.55, and just working that out, it comes to 7.7071, and that's our sigma. Now what are we going to have to do? We're going to have to work out the probability that our y for the normal distribution is going to be greater than or equal to 150. So let's have a think about how we're going to do that. Now to help us, I've just drawn some bars for a normal distribution here. Now if you look at it, we've got continuous data. So we want the values of y which are greater than or equal to 150, but can you see 150 is in the middle of its category there? So its lower bound is 149.5 and its upper bound is 150.5. So we want everything to the left of that, or sorry, to the right of that there. So we want 1 minus the probability that x is less than or equal to 149.5. And now we can use our normal CD function on the ClassWiz calculator. So once again, we want menu 7, we want 2 for normal CD. Now our lower bound is going to be 0, and we want to go up to an upper bound of 149.5. Press equals. Our sigma that we calculated earlier was 7.7071. Press equals. And our mu, which was our NP, remember, was 132. press equals, and if we press equals again, we get a value of 0.98841. So putting this down here, we've got 1 minus the value we just calculated, 0.98841, and that comes to 0.1158, and that's to 4 decimal places. And finally, for Part E, they said to use Part D and comment on whether or not the proportion of the company's PCs that germinate is different from the company's claim of 55%. Well, this probability 0.1158 is very small, therefore there is evidence that the company's claim is incorrect.